P transpose of A transpose. Here's the observability matrix in the form that we should do. It's inverse. And then it's all column zeros except for one. Yeah. Just doing the transpose. Pretty easy form for that. And you can use this MATLAB acronym for it. What you do is for acronym, you just put in instead of A transpose, instead of B, C transpose, and so forth. Okay, questions on any of this stuff? Kind of a quick introduction. Key points. Make an observer. We're going to try to estimate the state vectors. We want to make those estimates fast as we can. So we're going to choose poles for this thing to drive our estimates faster than what the controllers do. It also assumes what? Our model's pretty good. Our A, B, and C matrix we can trust somewhat. If we can't trust that, well, we've got to go to different type of controller, nonlinear controllers, or adaptive controllers, and other things. But we're assuming that our A matrix is good. Right? Not perfect, but it's close. It assumes that I can measure the output that's coming, all the states affect the output, so it's observable. Right? And it's a dual of solving for the control matrix. So, pretty straightforward. All right, questions on this? Yeah, questions on this? Okay. Example. Let's see. Here's yes. And on the exam, I wanted -2, -3. I found controllers. So let's assume now I can't measure directly x1 and x2. I can only measure y. Let's do this first part here. I'm trying to design an observer for this. My controller pole is at -2, -3. Where would you place the observer poles? Where would you place the observer poles?
-10, -15.
What was it?
-15.
-15, so make them each. What? 5 times faster? Right? All right. What is our observer? Since it's 2 by 2, let's do this by hand. What is our observer A matrix? dark to see. Okay. There's our A matrix for the observable form. It's the original A matrix, which is 0, 2, 0, minus 1, minus KE times C, which is 1, 1, right? And K is in what form? Column factor. Controllable to row vector for observable, these observers to be called. Okay, when we do this, yeah, so. This is K minus KE1, KE2. KE1, sorry. 2, KE2. Do that right? Okay. This is 0 minus KE1, 2 minus KE1, minus KE2, minus 1 minus KE2. Make sure I'm doing this right.
The first one should
What's
be,
that?
the first one
Oh,
should be minus one.
Did I, oh, minus, thank you.
You said minus one. didn't you?
Yeah, minus said, but chalk obviously didn't work. It's broke, that's why. All right, we need a characteristic equation. How do we get a characteristic equation? Si minus A, which is S plus KE1 minus 2 plus KE1 plus KE2, S plus 1 plus KE2. Alright, so this is S plus KE1 times S plus 1 plus KE2 minus KE2 times minus 2 plus KE1. Right. Squared plus S plus KE2S plus KE1S plus 2KE2 minus KE1, KE2, 0. This is cancel, thank you. Gather our terms. Is that right? This is 2, 1, 1, this is 2. And what do we want these to be? Poles are kind of 15, so our desired is what? 5 plus 150. Yeah, let's see, that says that KE1 plus So I picked the same type of calculation. All right, we'll do a lot of problems this thing today. The next thing we're going to do is, what's the structure of I put this observer and controller together in the system? And see what the consequences of the dynamics are. Yeah.
I had a question about the lab. The class schedule talks about a lab
Yeah.
next week.
Lab we're going to do next Thursday, and it's going to be, at least for those who not use the Quandra stuff, try to be there. Because I'm not going to be here next Thursday. First robotics is going on down at the Maverick Center, and who's volunteering for that? Thank you. Any more volunteers for that? More volunteers for that? We get everyone to volunteer for that? We need volunteers, obviously. So, yeah, this first one is quite simple. You're going to, for a simple motor position control system, design a state feedback controller. You'll have access to both position and velocity for that. Secondary. And then what you'll do is design that thing, go in the lab, and take about 5 minutes to actually make the measurements. Okay. I want to hold the here, right? Check to see if your response says the person. Guess what the next lab is? You make an observer for it. Same controller, but now all you can see is the output. You need to make an observer. So, who here has not used the Quandra stuff? Some of you have. You guys should try to be there Thursday. Tia will be in there how to everything set up. The rest of you have used the Quandra stuff. I think that's the same way as well. You use simulate things, and here for games. Yeah. All right, the lab.